Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0990, indicates an issue with the transmission fluid pressure switch E related to the 6th clutch in the Honda Accord, models from 2012 to 2017. This error occurs when the circuit experiences a high signal, affecting the proper shifting of gears within the transmission system. The transmission fluid pressure switch plays a crucial role in monitoring fluid pressure, which is essential for the operation of the 6th gear. If this pressure switch fails, or if there's a problem in its circuit, the vehicle may only shift into 3rd or 6th gear due to a fail-safe mechanism, impeding normal performance. The switch's position is typically located inside the transmission assembly. Proper understanding and troubleshooting of this code are vital for restoring optimal function to the vehicle's transmission. In summary, understanding DTC P0990 and its implications is crucial for effective troubleshooting and repair. This diagnostic trouble code indicates a high signal from the transmission fluid pressure switch E, which can significantly impact the vehicle's ability to shift gears properly. By following a systematic troubleshooting approach involving the assessment of the switch, wiring, and connectors, technicians can effectively pinpoint and resolve the underlying issues. Additionally, instituting regular preventive maintenance practices can help ensure that similar problems do not arise in the future. These preventive measures reinforce the vehicle's performance and reliability, making for a smoother driving experience. Ultimately, being proactive and informed about such diagnostics will benefit both the vehicle and the owner. This DTC P0990 specifically refers to the transmission fluid pressure switch E, which is integral to the operation of the 6th clutch in the Honda Accord. This switch monitors the hydraulic pressure within the transmission system and sends relevant information to the Powertrain Control Module, PCM. If the switch detects high pressure, or if it's malfunctioning, it contributes to shifting issues. The switch can be found within the transmission assembly, and it plays a crucial role in ensuring that the right amount of hydraulic pressure is maintained for optimal gear shifting. The PCM uses the information from this switch to adjust the operation of the transmission. When a problem is indicated by this DTC, it's essential to evaluate the transmission system thoroughly to address any underlying issues. There are several potential causes for the DTC P0990, each requiring careful consideration during troubleshooting. First, a faulty transmission fluid pressure switch E could lead to incorrect signaling, hence triggering the code. Additionally, poor connections or loose terminals between the switch and the PCM may interrupt the signal transmission. This can occur due to corrosion or wear over time. Furthermore, damaged wiring along the circuit could create shorts or interruptions in the signal path, which can also contribute to the high circuit status indicated by the DTC. Properly diagnosing these elements is crucial in efficiently resolving the issue at hand. The symptoms associated with DTC P0990 can significantly impact the drivability of the vehicle. One of the primary symptoms is a limitation in gear shifting, as the transmission may refuse to shift into gears other than 3rd or 6th. This is due to the fail-safe function deployed by the vehicle's system when it detects a fault. Additionally, drivers may notice the DTC light illuminated on the dashboard, indicating a fault code is present. Another potential symptom is transmission slipping, which could manifest as unexpected loss of power during acceleration. Understanding these symptoms assists in the quick recognition of the issue, leading to a more efficient troubleshooting process. The first step in troubleshooting DTC P0990 involves several critical actions. Begin by pressing the engine's start-stop button to select the on mode, which is necessary for initializing the vehicle's electronic systems. Following this, it's vital to clear the DTC using the Honda Diagnostic System, HDS, allowing the system to reset and potentially reveal any intermittent issues. Next, raise the vehicle securely on a lift or apply the parking brake if on the ground. This step ensures that you can safely inspect and allow the front wheels to rotate freely, an important factor for checking fluid dynamics and pressure readings. Each of these initial steps lays the groundwork for effective diagnostics, ensuring that the subsequent actions can be performed safely and accurately. In the second troubleshooting step, the first action is to ensure the vehicle is in off mode by pressing the engine's start-stop button. This is crucial before making any electrical connections or disconnections. Once confirmed, disconnect the transmission fluid pressure switch E, 6th clutch, 1P connector to isolate the circuit for testing. Following this, a jumper wire should be utilized to connect terminals A and B for continuity testing. After establishing the jumper wire connections, the engine should be turned to the on mode, enabling the HDS to monitor the parameter readings of the 6th pressure switch. During this phase, it's important to assess if the current conditions match the threshold specifications indicated by the manufacturer. If the readings meet specifications, the switch is deemed functional. However, if they do not, further investigation into other components is required. The final troubleshooting step requires specific attention to the vehicle's wiring integrity. Start by confirming the vehicle is in off mode, again, by pressing the engine start-stop button. Next, it is necessary to remove the jumper wire that was connected during the previous step. The next procedure involves jumping the Special Connector System, SCS, line using the HDS, which assists in ensuring that the diagnostic process is streamlined properly. Disconnect the PCM connector B, 51P, which is where critical communication occurs between the switch and the PCM. Employing a multimeter, check continuity between the specified test points to confirm the operational status of the OP6SW line. If continuity is confirmed, the wiring is intact. However, should there be no continuity, it indicates a failure in the wiring, requiring repairs or replacement to restore functionality. Once all necessary repairs or replacements have been made, the final verification step is essential to ensure that the DTC P0990 has been resolved effectively. Begin by clearing any stored DTCs once again using the HDS, emptying the system of any prior errors. Following this, conduct a test drive to observe the vehicle's performance under various conditions. This serves to validate that the repairs performed yielded the desired results, and that the vehicle can shift gears properly without interruptions. After the test drive, it's important to recheck the diagnostic data post-repairs to confirm that no residual codes or issues remain present in the system. A successful verification indicates that the troubleshooting and repair process has been effective and that the vehicle is ready for normal operation. Preventive maintenance plays a vital role in ensuring that issues like DTC P0990 do not arise unexpectedly. A periodic inspection of the wiring associated with the transmission fluid pressure switch is recommended to catch any signs of wear or damage early. It is equally important to maintain proper transmission fluid levels, as low fluid can lead to pressure discrepancies that could affect performance. Regularly checking all electrical connectors for corrosion or loose connections is also essential, as these can inhibit functionality over time. Establishing a routine for these checks can help maintain the system's health and prolong its lifespan, while preventing costly repairs in the future. By taking proactive measures, vehicle owners can enhance the reliability and performance of their Honda Accord. Please like and subscribe to the channel. See you next time.